Everyone, welcome back. Today we'll be starting off with a recursion. This is a topic widely used to solve many programs. Um, like in this video, we'll be talking about the factorial of a number. It's not just that only factorial of the number can be solved with recursion. Many of the program, like further we will see, it is solved by recursion, and recursion is a way that make a program really short and easy to understand. Okay, so let's get started with the topic, factorial of a number. Basically, what is factorial of a number? I'll not go into deeper, like just for understanding purpose I'm asking what is factorial of a number. So here you can see a short example taken as like number 5. So 5 is a factorial of a number. So 5 factorial, how we will find that? 5 into 4 into 3 into 2 into 1. So this is way how the factorial of 5 is elaborated as, and it will be sum to, you can just calculate this if we will this multiply all these things, like 5 was 20, 20 into 3 and then into 2, so it will be like sum to 120. So this only we will do but through recursion. Okay, this can also be done through a simple loop, but in this since we are studying a recursion topic, so I'll be explaining into that. Okay, so this is a program and this is a dry run which you need to follow, and so this is a C program that I have taken up, but the same thing, you the logic, keeping the logic same, you can do it in different language like Java, C++, Python, any language you can take up, but the logic remains same of that recursion. Just you need to understand how the things go up and how we do the drive in and what is the main concept regarding recursion. Okay, and the one thing that you should know before using this recursion is like recursion will be using a stack. So stack, that is last in first out, LIFO, that is I have written over here, LIFO, last in first out. This I'll explain you once I'll go into the dry run part. Okay, so let's get started. This program, first statement that will be executed is hashtag include standard input output dot header file. So this is a statement that will include all the header files into your program. Okay, so that you can use it. This is basically the input and output thing, that you can take the input from the user and print the output. So this is the header file that you should include in your C program. Okay, now since I have written the user defined function at the top, you can see that I have highlighted. Now this is a user defined function I have written in the top, but and the main I have written at the bottom, but you can the order doesn't matter. You can even write the user defined function at the bottom. Its order doesn't matter. But yeah, in some of the cases you need to include the function prototype in that case. So this topic I will cover in my video in which I will be executing and showing you. So let's keep this apart, like which should be at the top and which should be at the bottom. Let's focus on the how to do dry run, because that's very important in recursion. Okay, so this is a factorial int n. So and this is main. So basically two parts we can see in this program, and we'll start every time in any of the language, the program will start through main. Okay, program will start through main. Okay, so int number, then it's the int number in which we will be storing like which number we need to find the factorial, like 5, 6, 7, whatever, just a number. We have taken the number from the user, so we are printing like enter a number. Okay, then the user will be entering a number, and here you need to take care, like we will be writing scan f. So many people do it like scan and then f. So for understanding, it's scan f is just one word. Okay, and percentage d, it will be percentage is used to remove the character meaning of d. like it will convey to the compiler that it is a uh, percentage d is a special number. It's not a d character that need to be printed. So it will uh, keep the number content, like this number, whatever the thing will be stored in this number variable will be printed in place of percentage d. Okay, I think you should know this. Okay, this is very basic kind of programming concept that I'm telling now. Okay, so we'll come to the next fact. Fact is just a variable that I have taken long. Okay, long fact, just to store whatever the result will be. I will come up like 120. This I will get through factorial number function. This is a user defined function that I have defined it in the upper half of the program. So this will be returning me the final value. I will store it this output in this fact and then print it. So let's go to this fact. Okay, after this number is being taken, it will go to the factorial number. Okay, so factorial number, it will be here. Okay, so here we will get, like, for example, we have taken 5. Okay, 5 we have taken as a number. So here we will come up and we will start writing, because we are entering into user defined function, and since we know it's a recursion, so we will write like number, and initially it is 5. Okay, then if number is 0, this condition is false, so it will go to the else part, that is here. Okay, so return n into factorial of n minus 1. So what is it? So here it's like, you can see this function name, and inside of this function what it's calling, this same function. Okay, so here we will get to know that it is a recursion. Okay, so from the moment you find this statement, okay, this statement, that is a nested call. Okay, this whole function is there, but this is like a call from inside of the function, like first recursion that we'll encounter, we will write it over here. Okay, first recursion that we'll encounter, we will start writing. Okay, so here we were having number n as 5, so n into factorial of n minus 1. So return content we will write 5 into factorial of n minus 1. n minus 1, 5 minus 1, 4. So here we will decrement this 5 to 4. Okay, and we will write 5 into factorial of 4. Okay, now let's leave this 24 what I have written and 120. This is just once we will reach at the bottom, then we will start coming back. Okay, so that is first go through the how it is being called. Okay, so then again we got like factorial of 4. So factorial of 4, again it will go from here, it will again go to this same function with the value 4. Okay, so again we will go inside, is 4 equal to 0, false, else it will go return n into factorial of n minus 1. So this will be like 4 into factorial of 4 minus 1, that will the number will become 3. Okay, so here it will be 3. And one thing you must be wondering, that here I have written number or here I have taken as n. So it doesn't matter, because see, first of all I have taken number over here, so initially I have written here number, so you can also write n. That is the same thing. It's just for our understanding. Okay, you can take this as a n as well. Okay, okay, and we were in 4. Okay, 4 into factorial of 4 minus 1, that is 3. So here we have cut 4 and now it becomes 3. Okay, so we will write 4 into factorial of 4 minus 1, that is 3. Now we have reached till here. Now again it's calling factorial of 3. So again we will go to this function with the number 3. Now again we will check if n is equal to 0. No, it's false. So here we will come 3 into factorial of 3 minus 1, that is 2. So 3 into factorial of 2. Again we will go it with 2. It's false. Here we will come. So it will be 2 into factorial of 2 minus 1. So it will be 1. 2 into factorial of 1. Now again we will go with same factorial function with the value 1. So factorial function we went again with the value 1. So it will be 1 into factorial of 1 minus 1, that is 0. Okay, so 1 into factorial of 0. Now again we will go to this factorial function with the value 0. Now keep this in mind that this step now from on is going to be very just keep a track on what I'm saying, okay? Now this is very important, just listen carefully. Like now we are going with the value 0. So it is going to hit the base condition. Base condition is like something like recursion. What is it? Basically a function that call itself repeatedly until some base condition is satisfied. So if some base condition is not there, suppose it's not there, so this will continue. This will be 4 till 0, and then again it will become minus 1, minus 2, minus 3, minus 4. It will be non-stop. It will go till infinity, okay? So there should be a condition that stops this whole process, and that is somewhat called as a base condition, okay? So this in this factorial, our base condition is 0, because anything that we will multiply with 0 will become 0, okay? So there is no point in keeping 0 or minus 1, or there is no point of going further, okay? So we want only till 0, okay? So when our n is becoming 0, now it will return 1. To which function it will return 1? It will return 1 to this factorial 0, because it is somewhat like a function call. You must be wondering like why this 1 will be returning to this, okay, factorial of 0, okay? Why it will return to this? See, this whole long function will return some value here, okay? This factorial of number. You got this, because this is the usual thing that we will follow, okay? Function call is there, and the function call is getting some kind of return. So here also factorial of 0 is like a function call, okay? It will get some value, then only it will go and calculate some other things, okay? So this factorial of 0 will get a value return as 1, because that is my base condition from here. So this factorial 0 value will be 1, which I have written underlined with 1, okay? This one which I have underlined is the value 1. So factorial 0 value is 1. This value will be multiplied with 1, okay? Because it's in multiplication, okay? So this total answer will be 1 into 1 is 1, okay? So this one was, so one thing, this whole statement from where we got it? When we went to the function with the factorial 1, okay? We got this statement when we were at factorial 1. So this whole thing value will be the answer of this factorial 1, okay? So this 1 will be answer of factorial 1. So here I have written in a circle 1, because here same value will be there, okay? So this 1 now it will be is in a multiplication with 2, this whole statement. Now because before returning the value we need to calculate the whole statement, okay? So 2 into 1 will be 2 answer, okay? So this whole statement gives us 2. That is the answer of the previous call, okay? So this 2 is the same answer as this 2. Factorial 2 has the value 2, this one, okay? So 3 into 2, this whole statement what it will give? 3 into 2 is 6, okay? So this whole statement answer is 6. This will be the answer of the previous call, So here factorial 3 answer is this one. Previous call answer is this. Okay, now again we will calculate 4 into 6, that's 24. Okay, so 24, that will be the answer of previous call. Okay, so factorial 4 answer is 24. Now this whole statement will calculate 5 into 24, that's 120, and after this 120 will be returned to what? The final call here. The final call is here. This whole thing, what was the first call? First call was factorial of the number. So this 120, since this is the last statement of this whole thing, okay, our dry run, last thing of this whole recursion, this is called recursion dry run. Okay, so from the recursion dry run, 120 was the last number that we got as the output. Okay, so this will be returned to factorial of this number. Okay, this function call, this will be stored into fact. So fact is now containing 120. Now this statement is over. Now this statement is absolutely over. Now we will go to printf. Printf is just a simple print statement in C. Okay, factorial of percentage d. Percentage d is like taking the value from here. Okay, and is L percentage LD. Why I have taken LD? Because it is a like a number representing long. Okay, since I have taken fact as long, because for 5 factorial it is 120, but for other it might be a large number, so I have taken it long. Okay, so number, and so here we will close this double quotes, and first is number. So factorial of 5, number that was our number was 5, so factorial of 5 is fact, that is 120. Fact is storing 120 number. Okay, so factorial of 5 is 120. This will be the final output that we will get from this whole. I hope you got this. And what is this LIFO that I told? Last in first out, this is a stack. Okay, so you need to understand that recursion works on stack. Last in first out means the last function that we have taken will be the last in okay, see, in a simple way I will say we will go first in depth. Okay, like we will traverse this. First we will go till depth. Okay, and then we will come back above, like the stairs we have gone down, again we will come up, and then we will return the value. So it's like a simple way to understand stack. Okay, I hope you are getting this, because see, in factorial it might be easy to understand, but if you might go to other number like Fibonacci series or some other recursion example, these basic concept is like a pillar which will help you understand that concepts. Okay, so this is like you need to understand how the factorial is working with recursion. Okay, because there is a lot of sequence that you need to follow. Dry run is very important. How we are traversing the whole program, that is the important thing. And one more thing, one more point I want to share is like I will also be sharing a video of the execution of this whole program, in which you can see like which user defined function is above or main function is down, what statement that we need to add in order to keep the syntax correct. Okay, so that I can show you through a live demonstration of the whole program. Okay, I will be uploading that video as well, and we will, in the upcoming videos, we also be saying the Fibonacci series. So do follow the videos carefully and understand and keep learning.